What we're going to talk about in this video is something called wave-particle duality. And so this is a very nice conundrum to have because basically what happened was that the photoelectric effect showed that your waves can have particle-like properties. And so then it begged the question whether or not particles could have wave-like properties, and hence this blurring of the lines in what would then be a particle or what would be a wave. And so first let us understand what it means to be a particle. Basically, to be a particle, the key thing that you must have is mass, right? To be a particle, you must have a quantifiable mass, which means you can have something called momentum, because momentum is simply mass times your velocity. And to be a wave, well, waves, of course, do not have mass if you think about it. But waves can display some interesting properties such as diffraction, right? Or the ability to interfere. And so, if I can show that anything in this world, a piece of wood, a raindrop, an electron, light, if all of these things can have momentum and at the same time can have the ability to diffract or interfere, then it could be both a wave and a particle simultaneously. Now, this is a very strange concept, but one man who tried to put all this together was a gentleman named de Broglie. Okay, and he came up with the very nice equation, the de Broglie's wavelength lambda equals to h over p. And this is the equation that links waves and particles together. And so, if you look very closely at this, wavelength is something that you usually associate with waves. You do not calculate the wavelength of a piece of wood, but at the same time, you have p, momentum, which is a property of particles. And so it is very unusual to ask you to calculate the momentum of a light wave. Yet, this equation links it all together. And so, if I want to see how to use this equation, for example, if I want to calculate the wavelength of a particle, let me write that down, wavelength of a particle, then you have to use lambda equals to h over p because you can calculate the momentum of the particle. And so this gives you a way to calculate the wavelength of that particle. And at the same time, if I want you to calculate the momentum of a wave, then you can go P equals to H over lambda instead of using mv, because you will get undone by the fact that waves have no mass. But waves have a wavelength, which means you can calculate its momentum. And hence, de Broglie's wavelength, or this de Broglie equation, allows us to link wave and particle properties together.